So just a small update on this board that I've been trying to debug in the last video, and I got it working. And what I did was I soldered, made sure that every single pin on the chip is soldered properly using my microscope. And I also resoldered the pins to the oscillator and this ferrite bead. And I discovered that the ferrite bead was actually not properly, did not get a proper solder joint. And what happened was that when I desoldered one of the sides of it, it just fell off. So I resoldered it properly. And now the board is working and everything is powered. It's drawing a little bit less current than the other boards. It's at 60 milliamps. I have the previous board was drawing 0. Something like 90 milliamps. It varies sometimes, 80 to 90 milliamps. So I'm guessing there is probably some short somewhere, but I don't know where it is. I will probably find out when I start trying to bring up the other parts of the board. So I have two boards working, and I have another one that had a very similar issue. So I'm going to see if I can get that board working as well, using the same method of just making sure that the chip is properly soldered. So I have this board, and this one is not powering on properly. Let's see, it's at 50 milliamps, so it's something is not right here. So I'm going to see if I can figure out what it is. So the pins, they could be soldered, but I probably need to redo that. Or not redo it, but at least make sure that they're tinned. I can see that some pins are probably not making contact. So that's what I'm going to do first. And then I'll see this ferrite bead, make sure that it's connected. And it looks like it could use a little bit of resoldering. It's probably not connected. Actually, that's what I'm going to do first. And after that, I'll see if the board is working better, or at least the board is powering on. Because I don't know if this could be the actual issue. We'll see. So the ferrite bead goes to the VDDA, so the analog supply. And if it's not soldered properly, the chip is not going to have the analog supply. And I don't know actually if the chip will even power on without the analog supply. It could be that it doesn't work without analog supply. Okay, so let's see what we get now. Still getting, oh, we're actually getting 60 milliamps. So this could work. Most probably it won't work, because there are other pins that I think need to be resoldered. But it would be really nice if it worked. So I'm going to connect the serial debugger to this, and I'm going to try to flash it. Or actually, I'm just going to try to start a ST-Link. ST-Util. Yeah, that looks very good. So let's try flashing this. Maybe we'll get the LED to work. So it's flashing. That's awesome, and the LED is working. So I got 3 boards now that are working, which is nice. Check this out. So the LED is working. So it was as simple as that. It was just the fact that the analog supply was not connected, and that was causing the chip to not be. It was not possible to contact the chip through the ST-Link. So it seems to be very important that the analog supply is working in order to even be able to flash the chip. And this is it for this video. In the next video, I can move on to all other parts of the board. So this is going to be fun. Check this out. So this is going to be, we have analog outputs, analog inputs. We have buttons with debouncing. We have joysticks, encoder input, Hall sensor input, motor outputs, and EtherCAT, and 3 CAN buses. 2 normal CAN buses and 1 CAN FD. And the design for this board is available in all of the videos, and it's also available for sale, so you can buy this design. Obviously, I can only guarantee that it works to the degree that I've tested it, and I'm right now moving through the process of actually verifying this design and making sure that everything is working. So stay tuned and subscribe to my videos, subscribe to my channel to get notified about any live streams that I do, and I'll see you later.